Hey Cactus class, so this is a video of the extra practice related rate problems that you did in class so you can check your work. So for number 1, the oil from a ruptured tanker spreads in a circular pattern. If the radius of the circle increases at the constant rate of 3/2 feet per second, how fast is the enclosed area increasing at the end of 2 hours? So I have my picture of a circular oil pattern. I have a radius of r, because that's changing. And I am given that dr/dt is changing at 3/2 feet per second. I want to find dA/dt when t equals 2 hours. So that means my equation I'm going to use is the area of a circle. And I have dr/dt and I want to find dA/dt. So I can go ahead and take the derivative of the equation to get dA/dt equals 2 pi r dr/dt. Now I do have an r floating here, but here I have t equals 2 hours. So I need to find out what the radius is going to be after 2 hours. Well, if the radius is growing at 3/2 feet per second, and if the radius started at 0 when t equals 0 hours, we can figure out that the radius is 10,800. So I can go ahead and plug in what I have, do some simplifying to get 32,400 pi feet squared per second. For number 2, if gas is pumped into a spherical balloon at the rate of 5 feet cubed per minute, at what rate is the radius increasing when r is 3 feet? So here is my spherical balloon with the radius of r. I am given dV/dt, which is 5. I want to find dr/dt when r is 3. So I'm going to use the volume equation for a sphere, which is 4/3 pi r cubed. And since I have dV/dt and I want to find dr/dt, I can go ahead and take the derivative of the equation as given to get dV/dt equals 4 pi r squared dr/dt. I have dV/dt, I have r, which is 3. I want to find dr/dt, so I can plug in what I have, simplify, and solve for dr/dt, which should be approximately 0.04421 feet per minute. Number 3, at noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So here is my picture. Here's ship A sailing east and ship B sailing north. Oh, sorry, this is east. So the given is that dA/dt is going to be -35 because that's the rate at which my ship is sailing. And since it's sailing east, that means the distance from the starting spot is decreasing. That's why it's negative. And the ship B is sailing north, so its rate is positive because it's moving away, or their distance is increasing from my starting spot, which is 25. And I know that this distance right here is 150 kilometers west of ship B. And the 150 minus A is going to be whatever its distance is at that given time. And this is ship's B distance, which is B distance. And this is C distance. So I want to find dC/dt because that's how fast the distance between the ships is changing when t equals 4, since I started at noon. So 4 hours have passed. So I'm going to use the Pythagorean theorem to relate my variables. I can go ahead and take the derivative of each. I need to find the value of A and the value of B and the value of C when t equals 4. So in order to do that, I know that every hour A is decreasing its distance by 35 kilometers per hour. So that means after 4 hours, I'm going to have 150 minus 4 times 35, which will give me 10. And B is going to be 100, since it's going to be 25 every hour. And then to find C, I have to use the Pythagorean theorem. Now I can go ahead and plug in what I have. And I was able to cancel out the 2's. And I'm going to solve for dc dt. And I eventually will get 21.3933 kilometers per hour. Number 4. If a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, find the rate at which the diameter decreases when the diameter is 10 centimeters. So here's my picture of my snowball with the diameter d. I am given that the rate of the area is decreasing at negative 1 centimeter squared per minute. I want to find d dt when d equals 10. So I need the surface area formula for a sphere, which is 4 pi r squared. And in order to find r, I know that r is half of d. So I need to rewrite this in terms of d because I don't have a dr dt anywhere around here. But I do know I need to find a dd dt. So I rewrite r in terms of d so that I now have 4 pi times 1/2 d quantity squared. Do some simplifying to get pi d squared. Now I can go ahead and take the derivative, which will give me dA dt equals 2 pi d dt dt. Now I can plug in what I have. I have dA dt, I have d, and now I'm going to go ahead and solve for dd dt to get negative 1 over 20 pi, which can be approximately negative 0.0159 centimeters per minute. Number 5. A kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of the string have been let out? So here is my picture of a kite flying in the air. And it says that it's 100 feet above the ground, so that's a constant. And it has a horizontal distance, which I'm going to label as x. And it tells me that the horizontal speed is 8 feet per second. And I'm looking at the rate at which this angle between the string and the horizontal is decreasing. So I'm going to label that theta. And I'm going to label this distance from the person to the kite, so the distance of the string is z. I want to find d theta dt when z equals 200, because it says when 200 feet of the string have been let out. So I have to use something that relates these variables together. Well, since I'm dealing with an angle, I'm going to have to use something with trig. And for this problem, I chose tangent because tangent, it relates opposite over adjacent. And I did that one because the adjacent is x and I have the rate of x. I do not have the rate of z. So I can go ahead and take the derivative, which gives me secant squared theta d theta dt equal to negative 100 over x squared dx dt. All right, so I'm going to go ahead and solve for d theta dt first. So when I divide by secant squared, That's the same thing as multiplying by cosine squared. Now notice that I have an x here, but I don't have an x given. But I can find the value of x because I'm given z. And so since I'm given z and I have this side of the triangle, I can use Pythagorean theorem to find x. And after doing the Pythagorean theorem, you would get that x equals 100 square root 3. Now to figure out theta, you don't actually need to calculate theta. What you really need is cosine theta. Well, we can figure out cosine theta because we have the adjacent side, which is 100 root 3, and we have the hypotenuse, which is 200. So we can let cosine equal the adjacent side over the hypotenuse, so that I can plug in this for cosine theta rather than just plugging in a value for theta. So I'm going to plug in what I have, and I'm of course squaring the cosine because I have cosine squared down here. Now I'm going to simplify. Some things cancel, which is nice. And after doing this rest of the simplification, you should get that d theta dt is equal to negative 1 over 50 radians per second. And just so you know, every time that we're dealing with theta or angles, rate of change, it's always going to be radians. Last one. Number 6. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So here's the picture of my ladder and my wall in the ground. I'm going to label what I know is constant. The ladder does not change length, so I know that that's a constant, 25. I know that this horizontal distance changes, so I'm going to label that x, and the vertical distance changes, so I'm going to label that y. And since it's being pulled away from the wall, I know that the horizontal distance is going to be increasing. And so since I'm given that rate, that means dx dt is 2. And since the top of the letter is going to be going down, so the vertical distance is decreasing. So I know that dy dt would have to be negative. So I want to find, for part A, how fast is the top moving down the wall when the base of the ladder is 7 feet from the wall. So I need to find dy dt when x equals 7. So I'm going to use the Pythagorean theorem, take the derivative. I need to find the value of y when x equals 7, so I use the Pythagorean theorem with 25 and 7 and to solve for y, to get y to be 24. I plug in what I know. The 2's, of course, cancel. And once I solve for dy dt, I get negative 7 over 12 feet per second. Part B. Consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. So that means I want to find dA dt when x equals 7. So I want to use the area formula of a triangle, which is half base times height, but I'm using x and y for my base and my height. I can go ahead and take the derivative, and I'm going to have to use the product rule. And I just kept the 1/2 outside of the product rule. If you want to distribute it through, you can. And I'm going to plug in what I know. I have from the previous problem that dx dt is 2. From part A, I found that dy dt is equal to negative 7 over 12. And I also have the value of y, which is 24, and the value of x, which is 7. So now I'm going to simplify, and I get 527 over 24 feet squared per second. Part C. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 7 feet from the wall. All right, so here's the picture from the beginning. And I want to find the rate at which this angle between the ladder and the wall is changing. So I want to find d theta dt when x equals 7. So I need to write a trig function that relates what I have. And I'm choosing sine because I have the opposite, which is a nice number of 7, and I also have the hypotenuse, which is 25. So I'm going to take the derivative of this to get cosine theta d theta dt equals 1 over 25 dx dt. Now I have dx dt, which is 2. I'm looking for d theta dt, but I do not have cosine theta. But we can find cosine theta. We know that y equals 24, and we have that the hypotenuse is 25. So then I can let cosine theta equal 24 over 25. So I can plug in what I have and solve for d theta dt, which gives me 1 over 12 radians per second. Well, I hope this extra practice for related rates helped, and good luck on your quiz tomorrow.